This example comes out of section 5.4, Equations and Graphs of Trig Functions. So in this example we're asked to solve a trig equation. It happens to be a second degree trig equation, 4 cos squared x minus 3 equals 0, on the domain from 0 to 360 degrees, so we want all the answers that we'd find in there. We want to do it graphically and algebraically. Graphically just means you need to graph some part or parts of this equation and solve it somehow in your calculator. One way to do this would be to graph y1 equals 4. Now your calculator doesn't do cos squared the same way we have it written up top there, so you'd want to put something like this into your calculator, and if you did that, you would then not be looking for intersection, you'd be looking for zeros. So you'd make sure that your x window was clear at least from 0 to 360, maybe a little bit bigger, and your y window, you'd want to make sure you can actually see the whole graph. And if you did that, you'd be looking to press second trace 0 and find where these zeros actually are. If you do this algebraically, you're going to get the exact same answers. And let me show you what those answers are without, since I can't show you my calculator screen, we'll come back to the final answers of that. If I take 4 cos squared x minus 3 equals 0, I can say 4 cos squared x equals 3, cos squared x equals 3 over 4, and so I need to say cos x equals plus or minus the square root of 3/4. Now that might not look familiar to you until I say that's root 3 divided by 2. Now, if you're getting more and more familiar with the unit circle, hopefully you realize that if you were to punch that into your calculator and say inverse cos of root 3 over 2, that it would give you a reference angle of 30 degrees, or pi over 6 radians. But what we're looking for here is values that give us that in every quadrant, since we have the plus and the minus answers. So positive answers for cosine are in quadrants 1 and 4, so x is going to equal 30 degrees and 330 degrees. And then negative answers for cosine are in quadrants 2 and 3, and so we have answers at 150 degrees and 210 degrees. Turns out all 4 of those are answers to this question because we have the plus or the minus. These are, by the way, exactly the same answers you would get by doing second trace 0. You'd realize that you have 4 answers, and you'd say, oh, the first one is 30 degrees, the second one is 150 degrees, the next one 210 degrees, and the last one 330 degrees. And you should confirm basically in all cases, graphically and algebraically, you get the same answer for a trig equation as long as you've solved it correctly.